continuing on with the axial skeleton, we've already talked about the skull. Now we're going to talk about the vertebral column, the ribs, and the sternum. So when you talk about the cervical vertebra, which is the first region just here, birds have an incredibly large number of cervical vertebra, more than any other vertebrate. It's usually somewhere between 14 and 25. And it's really one of the main parts of the vertebral column which is not fused. And that makes perfect sense when you think about it, because unlike most of the skeleton, which is highly adapted for flight, this part of the skeleton is not. It needs to be very flexible. It's going to be used when the bird is probing for food, when it's preening. We have special joints between one vertebra and the next called saddle joints, and this allows lots of flexibility. The other thing when you think about it is when the bird's on the ground, it needs to really be able to keep an eye on predators. Then we move into the next section of the vertebral column, which we'd probably refer to as the trunk vertebra, and there's a great deal of fusion going on in this region. So we often have 3 thoracic, several lumbar, maybe 7 lumbar, often a couple of sacral, and maybe even about 5 caudal, and they're all fused together, so there's no independent movement between them. Also, the pelvic girdle back here is fused onto the vertebral column as well. So the ilium of the pelvic girdle is fused on. This gives us a short, rigid back, and it minimizes the number of muscles needed to keep the bird streamlined, particularly when it's flying. If you've watched a bird when it's on the ground, because of the way the pelvic girdle is fused onto the backbone just here, then you've seen the way they move. They have that sort of teeter-totter stance where they sort of go to one foot and then to the other foot. So that's partly because of the fusion that goes on. It gives very good support for the hind limbs, and that's especially important during both taking off and also during landing. That whole fused region of the vertebral column is usually referred to as the synsacrum. Following the synsacrum, we have a few independent vertebrae just here, which are not fused, caudal vertebra. And then at the very end of the vertebral column, we have some more fused caudal vertebra, usually around 4 to 7, and that's known as the pygostyle. It supports the tail feathers, and the tail is used for lift, for braking, and for steering. Then if we look at go back here to the trunk vertebra, on many of the trunk vertebra, we're going to have ribs attached. So go underneath here, we can see the ribs. And the interesting thing about these ribs is they are hinged, and they also have little processes on them from one rib to the next. So hinged allows them to move up and down in respiration. And in particular, when you think about how a bird respires, they have what's called a fixed volume lung, so that doesn't actually change shape, but they use air sacs, and the air sacs work a bit like bellows. And by the movement of the ribs, the flexibility there, they're compressing the air sacs, which is drawing air in or forcing air out. They have amazingly efficient lungs with a one-way flow of air. So unlike our own lungs, there's no mixing of carbon dioxide and oxygen. The unsuccate processes, which are these little processes on the ribs, help strengthen the rib cage. It needs to be particularly strong. In particular, we don't want it to collapse with the downward movement, with the thrust of flying. The other thing we notice is in most birds, they have a very, very large sternum just here, and usually a huge process coming out from it that we'd refer to as the keel. And that's where the major muscles associated with flying will be attached. We've got the pectoralis, which depresses the wing, and we've got the supracoracoid, which raises the wing. And these muscles are massive. They make up about 25 to 35% of the bird's body weight.